Good day, grade 12s. Welcome to our technical mathematics. I hope you are fine. And then I also hope that you are busy with your studies. You are practicing mathematics. Make sure that you do practice this technical mathematics for trial exam and the final exam. And then as you can see on the screen that today we are going to be dealing with calculus and integration. So that is the two topics that we'll be looking at for today's lesson. Now we can first start with the content of these two concepts. Now, under differential calculus and integration, we have the application of what? Differential calculus. That this is the topic that we'll be talking about for today's lesson. And next, then we'll be talking about the integration, right? So this is a very important topic. Remember, it forms part of what? Paper 1. Okay, so please do practice differential calculus as well as the integration. It's very important. And as you prepare yourself for trial exam and also the final examination, right? Now let's get into our business for today. Then we're going to start with the application of calculus. Now, in order for you to be able to solve what? The maximum and the minimum problems, or the problems in real life situation under calculus, then when you are dealing with those questions, first you have to highlight what the question asks and make expression for what has to be maximized or minimized. Draw a diagram if possible. In some cases or in some scenarios, then it's going to be much better or simpler if you draw the diagram, so that you can be able to understand what you are talking about. Then you also have to do what? If there are two variables, for instance, if let's say you have x and y, then try to eliminate one using the given information and simultaneous equation. Okay. Then write down f of x and f prime of x. When you start doing what? Solving the maxima and the minima, right? Then that's what you're going to start writing. You're going to write f of x and f prime of x when you start deriving, okay? Remember, we are still under calculus, and then we have touched what? We have touched derivative. We know derivative if we want to derive, and then what we do, for instance, in this one we have, let me just show you. You can see when you derive from here, it's going to be what? F prime of x. Then we can see that this person have derived, right? The last point, it says set the derivative equation to 0 for maxima or minima. Now, after you have derived, then you're going to equate that derivative to 0 so that you can be able to solve what? The maxima or the minima value, right? So that's how you should go about the application of calculus. So we are going to have problems where we are going to solve and understand on how are we supposed to answer this question when it comes to trial exam or the final examination. It's a very important and very interesting topic where you need to understand certain aspect on how do you go about it. All right. Now let's proceed and see what we're going to have under this. Now we have example 1 under application of calculus. Let's see what we're having so that we learn on how do we do the application of calculus now. All right. Now let's read our scenario and see what we're having. The Department of Energy plans to build a rectangular wind, as it's shown below. You can see this is a rectangular power plant having an area. We are now giving what? An area. We are having an area of 360 kilometers squared and surrounding surround it with a fence. The length of the power plant is X kilometer. You can see just underneath this rectangular, we have a X there, meaning the length of this rectangular is X. And then we also have the area of this rectangular wind plant or power plant. Okay. Now, the first question says, write an expression for the width of the plant in terms of what? In terms of X. Write an expression for the width of the plant in terms of X. Now, I just want to give you an idea or a clue on how can you answer application calculus questions. Application of calculus questions. It's very simple. Now, from the scenario, we have to see what we are having. For instance, you can see from this scenario, we are given what? The area, right? The area. So once you have the area, for you to be able to answer the first question, then you have to start writing the area, because now from the scenario, we are having what? The area, right? And then let's see on how do we do that. Now, first, because now we are being given what? Only the length of this rectangular, which is X. Then we don't have what? The width or the breadth. We don't have that. Now we are going to give it a name. In this case, we can say that let width be equals to what? Y. Now this side, we're going to take it as what? As Y. Meaning the width in this case is Y, and the length in this case is what? Is X. Okay. Then we are going to start writing the area first. The formula for the area of rectangle. You start with the area equals to length times breadth, or times area equals to length times width. Okay. Then the next step, what you're going to do, since we are having area, like I said, that for you to be able to answer the first question, it will depend on the scenario. What are we having from the scenario? And then in this scenario, we can see that we are having what? We are having the area. So now we are first, what we have to do, you have to write the area formula for this particular shape that we are having. And in this case, we are having what? We are having rectangle. A rectangle. And then you can see for area, we have 360. And then length, we all know that the length is X. And then width is Y, right? Now, since they say we should express the width of the plant in terms of X, and then we have let the width to be equals to Y, and then therefore we are going to make Y the subject of the formula, so that we make width in terms of X, meaning when you solve for width, it should be having what? X. Then in this case, it's very clear that we're going to divide with X, so that we can obtain what? Y equals to 360 over X, right? Then we have answered that question that says write an expression for the width of the plant in terms of X. Okay. And then you can also do what? You can also leave it with width. You can leave it with width, and then you just have to say width equals to 360 over X, right? But in this case, we tried to make it very simple for you to see on how do we do that. Now let's go to answer the second question. It says write an expression for the perimeter. We are now looking for the perimeter of the plant in terms of what? In terms of X, right? And I believe that my dear learners, that you are familiar with the perimeter, especially for the rectangle. You know that perimeter is the length of all the sides, the sum of all the sides, this side plus this one and plus this one, then it will give us what? It will give us the perimeter. Now, how do you write that? This is the formula perimeter. You remember, 2 length and the 2 what? Width. Why 2? Because remember, we've got two lengths. The length on top there, we have another length just below there. And then we have what? Width this side, we have another width this side. So hence, we're saying 2 length plus 2 width. Now, since these people say that we should express this perimeter in terms of x, then and then what we have, we just have to substitute there. 2, we have 2L, we know L, our length is x, then 2, and then the width. Remember, we have determined the width in terms of x from question 1, right? So where you see the width, then we're going to substitute with what? 360 over x, and then this is the case, right? Then you try to simplify it, then our perimeter in this case, in terms of x, is equals to 2x plus 720 over x, right? Then we have answered the question, okay? Now let's proceed. The third question says, determine the dimensions of the plant if the perimeter is minimum. If the perimeter is minimum. Now, in order for you to determine the dimension, and then in this case, they're talking about minimum. Remember earlier on, we spoke about setting a derivative and equate to 0 so that you can be able to determine the maximum and the minimum, right? Now, in this case, you can see that we also have to do what? Do the minimum, right? So once you come across this word minimum or maximum, you must know that you have to derive. So you have to create equation like we did here. You can see that we are going to derive with respect to x, right? We're going to do derivative with respect to x. So we are going to say p of x equals to 2x plus 720 over x, okay? Then the second step, what we have to do, we cannot derive. First, remember, there are rules before we do the derivative. You can see we've got 720 over x, then we need to rewrite it because remember one of the rules before you apply derivative, then you have to remove the division sign so that you can be able to derive. Now, in this case, we tried to write this in this form where we have 720x to power -1, right? Then once you have reached this stage, then you can be able to do what? P prime. Now you start deriving. Now, after you derive, you just apply the rules of derivative. Then we know that 2x becomes 2 minus, then you're going to drop this -1 this side. So -1 multiplied by 720 is going to be -720 x to the power -2, right? Then you then equate to 0 as we said earlier on, so that you can be able to solve the value of x. And then where you see this, then is 0 there, then you are solving for what? For x. And then we transpose this 720 over x squared on the right, on the left hand side, then we are having what? We're having this, right? And then because now we are, then after that we're going to do cross multiply. After we've done cross multiply, then you're going to divide with 2. Then we're going to be left with x squared equals to 720 over 2. Now, because since we are in need of x, then we need to get rid of this. We need to get rid of exponent 2. Then we're going to square both sides. And then we're going to say plus or minus. The answer is going to give us 19 kilometers. Therefore, the answer that we are looking for is 19 kilometers. So that's how you should go about it. Every time when you come across a question that needs to calculate the minimum or the maximum. Then we can proceed. All right. Now we still have another example under application of calculus. All right. The scenario that we're having, it says a farmer wants to make a rectangular chicken run using an existing wall as one side. He has 16, in this case, we are now having what? 16 meters of a wire fencing, right? Then the first question says, if the length of the chicken run is X meters, the length, meaning from this point here to this point, then the length is X meters. Write an expression for the area, right? Now, before you answer this question, remember earlier on, I said you are going to be guided by what? By the scenario. What are we having from the scenario? In this case, we can see that we're having 16 meters, right? And then it shows that the length of this fencing is 16 meters. And then in order for you to get the length of all the sides, remember we're using what? We are using the perimeter. Now, before we can answer the first question, we first need to start with the perimeter, because from the scenario, we're having what? The length of the wire fencing, right? Then let's see on how do we do that. Now, we are going to let the width to be equals to y, because since we are having the length as x, then this side, we are going to take it as what? As y, right? So we're just giving it a name, which is y. Then we're going to start with what? The formula of a perimeter. But from the previous slide that we worked on, remember we also wrote the formula for perimeter. But look at here, it's no longer what? 2L, 2 length, right? It's no longer that. Why? Because if we come to this structure here, or this picture here, they said that the other side is already existing, and this side, which is a wall, right? So there is no need to write 2 length. We're only going to work with this length here, which is x. So in this case, we're only having what? Only 1 length. But as for width, we have this side, and we also have what? This side, meaning we have 2 what? Width, right? Hence we're having what? 2 width. But as for length, it's only 1 length, because this side, it's that side of what? It's a wall, it's already existing, that side, right? So there is no need for us to write 2L. Then the second step, since we're having 16 meters, we know that is a what? It's a perimeter. Then where you see P is 16, and then our length in this case is X plus 2Y, right? Because we said width, let width be what? X, I mean Y, right? Then it's going to be 2Y. Now, since we need to eliminate one variable, in this case, we are going to eliminate what? Y. Then we're going to make Y the subject of the formula. Then you can see that I've transposed this X on this side. Then we're now going to have 2Y equals to 16 minus X. Then because now I want to make Y the subject, then we are going to divide with what? With 2 both sides. And then, then after we have done that, we have to answer the question. Remember, the question was saying that if the length of the chicken run is X meters, write the expression for the area. Now, after you have done, or after you have just made Y the subject of the formula, you write the formula for area, which is this one. Area equals to length times breadth, or width, right? Now, the length, we have X there, and the width, remember we have determined it in terms of x. In this case, we can see is 16 minus x over 2. Then where I see width, I'm just going to substitute with 16 minus x over 2, right? And then the second question, it says find the dimension. Now we are looking for the dimension of the chicken run that will give the maximum area. Remember, I said up when you come across the word maxima, you must know that we have to start deriving. Then we're going to use the rule of the derivative to solve or to determine the value of x in this case. Now we can see that we have tried to write it in terms of a of x, right? Because we're going to derive with respect to x, meaning we are in need of x this time so that we can be able to determine or to find the dimensions, all right? The dimensions of the chicken run. The second step, then we're just going to apply the rules of differentiation. Now we can see that before we had 8x, now it's become 8. And then in this case, if you drop this 2 to this side and you multiply 2 by this -half, then you're going to have -1. Then and say x squared, then this exponent 2 you're going to minus with 1, then you're going to be left with exponent 1. Then hence we're having what? -x. Then after you've done that, then you're going to equate to 0 so that you can be able to solve the value of what? The value of x. Then you just equate to 0, then our value for x is 8 meter. 8 meter. So it's very clear that the length, because since the length is x, then we have just determined x, then it shows that that length is 8 meter, right? But we don't know the other dimensions with it, which is the width. Then since we have obtained where y is the subject, in this case from question 1 there, it say y equals to 16 minus x over 2. Then where you see x, you just substitute with this 8, then it's going to give us our width, right? So in this case, you can see is what? Is 4 meter. So we have answered the question. So let's proceed and see what we'll have. We are still having another example and application. All right. Now let's read the scenario that we are having. It says a manufacturer needs to design a closed box having a base where the length is twice. Let me underline, it's very important. The length is twice the width. The surface area of the box must be exactly 120 centimeters squared. Now let's come to this picture here. We can see that our width in this case is what? Is x. And then from the scenario, they said that length should be twice the width. Now the length should be twice the width. And then in this case, you can see that the width is x. Therefore, then we're going to have what? 2x. Sorry, let me just remove that and try to write let me just write 2 and try to write 2x so that you can be able to see. Let me write 2x. Okay. All right. Now the first question, write down the expression for the length and the height of the box in term with the width is x centimeter. It says write down the expression for the length and the height of the box if the length is what? Is x centimeter. Now, let me repeat it. For you to answer the first question is going to be informed by the scenario. What are we having from the scenario, right? Then you can see that we are having the surface area, which is 120 centimeters squared, right? So now, if that is the case that we're having surface area, then once you start answering the first question, you write the surface area formula, and then you try to substitute everything and then answer the question or what the question needs to for us to solve. Now let's see on how do we do that. First, you write the surface area, which is equals to 2 length times width plus 2 width times height plus 2 length times height. So that is the formula for surface area for this box. Okay. Then the second step, because now we are having a surface area from the scenario, which is 120 centimeters squared. Therefore, and then 2, what is our length? We agreed that the length is 2x because the length is twice the width. So there is going to be 2x, and then the width is going to be x plus 2, and then the width is x, and the height is what we don't have, and then plus 2, the length is 2x plus the height. Okay. Now the second question, we then simplify it to 120, and then we know when we multiply this, we're going to have what? 4x squared. Then this 2, you can see we're having this. And then since we want to make the height the subject of the formula, then we're going to transpose this 4x squared to the right, to the left hand side. Then it's going to give us 120 minus 4x squared equals to what? 6xh. Then we want to make h the subject of the formula. Therefore, we are going to divide both sides by 6x. Then this is what we're going to obtain. Then if you simplify it, then it's going to give us 20 over x minus 2 over 3x. So that is h in terms of what? In terms of x, right? The second question, show that the volume of the box is given by the formula this. So in this case, if they are talking about the volume, you just write the formula for volume, then you substitute everything that you are having, then you simplify it until you prove that volume equals to 40x minus 4 over 3x cubed. So the formula for this box is volume equals to length times width times height. Then we all know the length is 2x, the width is x, and then since we have determined the height in terms of x in this case, then where you see the height, then we go to substitute with what? With 20 over x minus 2 over 3x. And then this is what we did here. And then we're going to simplify it until we obtain this. All right, now we just multiply it, and then we have the final answer that we are looking for. So we have proved that the volume is equals to 40x minus 4 over 3x cubed. All right, because we're going to open bracket with this 2x squared, because it's going to give us 2x squared. So if you multiply each term inside the bracket, then you're going to produce this, or you're going to get this. So we have answered the second question. The last one, what dimensions will produce the maximum value? Again, if you are looking for dimensions and we're going to be determining the maximum or the minimum, then you're going to do what? The derivative now. You're going to do the derivative. Then you just derive 40x becomes 40. And then remember, for this one, you're going to drop this 3 this side. Then if you multiply 3 multiply by negative 4 over 3, then you're going to get negative 4. Then remember this exponent 3, then you're going to minus with 1. Then you're going to have now exponent 2. Thereafter, after you have applied derivative, then you're going to equate to 0. Let's equate it to 0 and see what we're having there. All right, let's wait for the system. It's very slow. All right. After you have derived, then you are going to equate this to 0. Then let's equate it. Then after you equate to 0, then you're going to transpose this negative 4x squared to the left-hand side. Then since we are calculating for the value of x, then we need to get rid of this squared there, this exponent 2. Then you're going to square both sides. Then you're going to have what? Plus or minus 10. Then, but the value that we're looking for is this positive what? Positive 10. Okay? So we can see that in this case, since the width is x, then this side is going to be what? It's going to be 10 centimeter. Of course, the length is twice that, meaning it's going to be 20 because it's 2 times 10, which is 20 centimeter. Okay, then let's proceed and get example 4. We're still under application of calculus. It says, Mr. Shoba built a rectangular fish tank. The length and the breadth and the height of the tank are 3x meters, 1,5 meters, and 1 minus x meters, respectively. As shown in the diagram below, we can see from the diagram here what is our length and then what is our width and also what? Also the height. Okay. Now the first question, determine the formula for the volume of the tank in terms of what? In terms of x, right? Then let's see on how do we do that. First, write the formula for the rectangle, which is what? The formula for the volume is volume equals to width times height times length. Then let's do that. Then you're going to substitute everything. And then after that, you're going to simplify it until you reach to the final stage, which is negative 9 over 2 x squared plus 9 over 2x. All right. Then we just answered the question that says we should determine a formula for the volume of the tank in terms of x. And then when they say in terms of x, make sure that the final answer should have what? X. You can see our final answer has x squared, and the other side is x, right? So you've just answered the question. Number 2, it says, hence determine the value of x. That will maximize. Remember, you come across the words maxima or a minima, then you must know that you have to derive. You have to apply the derivative, right? Then you're going to write it in this sense where you have volume of x, which is v of x equals to this, because we are going to be deriving with respect to x. Then we just apply the rules of differentiation, and therefore this is what we are going to get, which is negative 9x plus what? 9 over 2. Then the third step, then you know that we have to equate to 0. in order for us to solve the value of x. Then we equate it to 0. Then what we did in this case, because now we are solving for x, then what I did, then you can see that we are having a fraction there, which is 9/2. So to get rid of this fraction, you are going to multiply each term by the denominator of that fraction. And you can see the denominator of that fraction is 2. Then we are going to say 2 times 0 is 0 there. And then negative 9 times x times 2 is going to give us what? 18x. And then obviously this one is going to be 9, right? And then we're going to divide both sides by 18. Then our x, the x value is going to be 1/2. So that is the value of x that we had to determine, right? So it's quite simple. And then let's proceed. Now we are going to be talking about the rate of change. The rate of change. It says whenever you are dealing with the problem where the variable is changing, with respect to another, you will have to use the differentiation. Meaning, if you start changing the variables, right, or the rate of change, then you have to start deriving. You have to derive. We are going to apply derivative or differentiation. Now let's get an example where we are going to apply that sense. Now it says, during an experiment, a learner must record the velocity, which is v, of an electronic toy car over a distance m, and then t seconds. The experiment has begun. The velocity of the electronic toy car is given by this formula there, which is v of t equals to 8 plus 4t minus t squared. The first question says we should determine the initial velocity of the toy car, right? Then when we refer to initial velocity, it means it's just starting, right? So in terms of time is going to be 0 because we haven't started, right? We are at the initial velocity. The car is not yet started. So we cannot be able to count time, right? So in that case, or in that sense, our time is going to be equals to 0. So whenever you see t, then you're going to substitute 0, and then the velocity of that particular toy car then becomes what? 8 meters per second. Okay. The second question says the velocity of the car when time is what? Time is now 0.2 seconds. We want to see or want to know what is the velocity of that car. Then wherever you see t, then you're just going to substitute with what? 0.2, and then you're going to give us what? 8.76 meter per second. The last question, the rate at which, then we just want to underline that, the rate at which the velocity changes. Remember earlier on we talked about variable changing, right? Where it is changed. Now, with respect to time, when time is equals to 1.2 seconds, remember we apply what? We are going to be applying the differentiation, right? Then let's see on how do we do that. Then you're going to write this formula that we're having. Then you're going to start deriving it. Then you're going to apply derivative. Then after you have applied the derivative, which is 4 minus 2, what? 2t. Remember the rules. If this 8 is going to be what? We consider this 8 as the constant number, and the constant number becomes what? 0. And then if it's 4t here, it's going to be 4. And then this one, if you drop this to the side, then it's going to give us negative 2t. Thereafter, where you see t, then we're going to substitute it with 1,2 seconds. Then this is what we are going to obtain, which is 1,6 meters per second. So that is the rate of change. That's how you should answer this question under rate of change. It's a very interesting question, and it's very simple to answer. You just have to understand when to apply differentiation. When to apply differentiation. When they talk about the rate at which something changes, right? But in this case, we remember we're talking about what? Velocity. So the velocity changes with respect to time now. That's where we're going to start to apply the rules of differentiation, or we're going to derive. Okay? Now let's proceed. Now, we'll be talking about the integration. We are now going to be looking at integration. Now let us read what is happening under integration. It says, after completing this integration, you must be able to apply the standard form of the integrals as a converse of differentiation. So it's a converse of differentiation, meaning if you take differentiation, if you take integration, right? Meaning the integration is the antiderivative of what? Is antiderivative of differentiation. Okay? So hence they are saying the integral as an converse of what? Of differentiation. So if you know differentiation, then it's going to be easy for you to understand on how do we do or apply the integration. Then you must also be able to apply the rules for integration for the functions such as kx to power n, where n is the element of all real numbers, but n should not be equals to -1. And the other one is say k over x, right? And then this is what we are having as well. And the last point there, it says we should apply the integration to determine the size or the magnitude of an area included by the curve and the x-axis, or a curve, the x-axis and the ordinates, where x equals to a and x equals to b, right? Where a and b are element of all integers. So that's what we are going to be looking at under integration. Let's see what we're having. The first example under integration, and then we just going to be applying the rules that we have learned during lessons. The previous lesson that we had, you just have to apply the rules of integration, right? So that it can be easier for you to answer this question here. Then the first question we say, determine the following integrals. And then this is what we are having. So we need to do the integral of the first one and also the second one. Now the solution, so this is what we are having. Now remember, when we have this 6 over x, right? If the denominator becomes x, then that's where we're going to introduce what we call ln. Now the answer for this one is going to be -6 ln x plus c. It's very, very important for integration. After you have integrate, then don't forget to also include what? The c. So every time when you integrate, you also include what? Plus c. It's very, very important. And they sometimes give you a mark just to write plus c. So my dear learners, don't forget to write that. It's very, very important. So after you just apply the integration, you just have to add c. Okay? And then let's answer the second one, which is integration of the integral of what? X minus 1 or squared, right? And then let's see how do we go about it. Then, okay, you can see from the second step, we haven't what? Integrate. Why? Because now we are having x minus 1 all squared. So we need to rewrite this and try to fix it. It's the same as what? It's the same as the differentiation. Remember, there are rules under differentiation, or things that we need to remove first, or we need to rewrite them before we can start deriving, right? The same applies with what? With integration. We need to fix this one first. We need to open the bracket, try to multiply them, and then we can now have, and from the first step to the second step there, you can see that what we did, we repeat this bracket twice because it says squared. Then we apply what we call FOIL. Then we're going to obtain what? X squared minus 2x plus 1 dx, right? Because we haven't start integrating. That's why we have to write what? Dx. Then we can see that second step, everything is okay. We don't have to do anything. And then we just have to proceed and start to integrate. And when you integrate, remember I also indicate that integration is the antiderivative. It's antiderivative of differentiation. So now remember, for exponent 2, we are going to add with 1, and what we did from this exponent, then we're going to divide with it. Now we're having x cubed over 3 minus 2x squared plus, over 2 plus x plus c. Then don't forget again to write this c at the end, all right? So this is the answer. This is the answer for that. So it's quite simple just to apply the integrations. It's very simple. Just have to practice more and more under this, so that when it comes to your exam, you just collect all those marks. Now let's proceed. We are still having another examples under integration, and let's see. All right, determine the integral of this. Determine the integral of this, right? Now we can see that we're having what? A division sign there. We're having division sign. Like I said, that before you can integrate, you have to rewrite what you are having, so that you get rid of division sign, you get rid of brackets, and the last one, I think we're going to be getting rid of what? The root sign. All right, the root sign. But this one, you can see that we have in division sign. Then we're going to rewrite it and see. The second step, we're going to say 2x to the power 8 over x cubed plus, then you're going to do the same with others. Then this is what you're going to have on the second step. Therefore, we are going to simplify it. We know if you divide everything, every term there, then this is what you're going to obtain, which is 2x to the power 5 plus x squared minus 13x to the power negative 1. Now, remember, my dear learners, before you start integrating, you continue with the sign of the integral sign. You continue with the integral sign. You can see that second step, then the third step is still there, this integral sign, right? If you only stop writing it when you start integrating, okay? Now let's start integrating, because everything is okay. You can see that I've just say equals to, then you just integrate the first term, the second term, and the third one. Then the last you say plus c, all right? So this is the answer for this particular question. Now we can proceed. The integration, determining the magnitude and the area. We are now going to be using the integration or the integral to determine the size of an area, or determine the area of a curve, right? Or area under the curve. Applying the integration to determine the magnitude of an area where we are going to apply definite integrals to calculate the area under the curve. A definite integral is defined as what? You can see the integral sign there. It has b on top, a that's below there, f of x dx. Now it's very clear that b, they say it's upper limit, right? There's the upper limit. And then a is lower limit, right? So when we have to determine the magnitude of an area, then we're going to use the definite integral. Remember earlier on we were dealing with the indefinite integral. Now we are dealing with definite integral, where we are having the upper limit and the lower limit. And then you can see from the sketch here, if we had to calculate the area of this shaded part there, then the first one is going to be what? Is going to be lower limit. And the second point there is going to be our upper limit. Okay. And then let's see on how do we calculate that. Okay, we're still under this. Let's first apply the rules of integration, and then let's apply them. The first one, it says the integral of 3 over x. This what we're having is going to be 3 ln x plus c, all right? 3 ln x plus c. And then the second one, now remember, it's going to give us this x cubed over 3 plus pi x plus c, all right? Now remember, this pi, we are going to take it as what? As the constant number. Then when you reverse this, then it's going to give us what? Pi x plus c, okay? The third one, we can see that we are now integrating with respect to t. Can you see this? It's no longer what? Dx. So every time it's very important to check what are we integrating. In this case is dt, right? Now we can see for t squared, then we're going to have what? A t cubed over 3. And the second one for t is going to give us t squared over 2. And then x, remember when it's antiderivative, if you reverse, then it's going to give us what? Xt plus c, right? So that's how you should answer them. And then let's proceed. Now, example 1, under area, we are now going to be calculating area using the integral or the integration, right? Where we are going to apply what you call definite integral. The sketch below represents the bounded area of the curve of the function defined by this. Now, the function this or the equation this, you can see is a parabola graph there. You can see the parabola graph, which is defined by this equation, which is f of x equals to x squared plus 3. All right? Determine the shaded area. You can see this is the area that we are looking for, the shaded area. This is the area bounded by the curve and the x-axis between the points where x equals to negative 2 and x equals to 1. Now we can see this point here, we're having negative 2 here, and the last point is what? Is 1. And then earlier on, remember, I tried to show you if you are looking for lower limit, and then if you are looking for upper limit, which values are you going to use? And then let's see on how do we answer this question. Then you're going to write the integral sign, where you're going to have or include your lower limit, then you can see that the lower limit in this case is -2 and the upper limit is 1. Then you take the equation that we're having of that particular curve. In this case, we're having x squared plus 3. They can see x squared plus 3 dx. Now, remember, we are looking for what, or we are determining what? We are determining the area, right? Area under this curve. You can see is the area under this curve. So we are calculating that area there. Then let's see how do you go about it. Now, first we're going to do the derivative, the integral of x squared, then it's x cubed over 3 of 3 is 3x. Then you are going to put your upper limit on the right hand side. You can see it's 1, and the lower limit in this case is -2. The third step, then you're going to you start substituting what? Your upper limit. Where you see x, for instance, you can see the third step that instead of x, you just put 1 there, the 1, then you say minus, you always write minus, then you take the lower limit, which is -2. You can see where you see x, you just put -2 and also -2. Then you press everything on your calculator there, then you're going to obtain what? 12 units squared. Remember, you are calculating for area, so it should be a unit squared, right? Unit squared, to show that we are calculating area. Area should have that exponent 2, okay? So you are done answering that question. That's how you should answer what? The area under the curve using the integral or the integration, okay? Let's get another example. All right. All right, example 2, the graph of f defined by f of x equals to -x cubed plus 6x squared is drawn below. We can see this is the graph of cubic, and then and it's clearly shown the area that we'll be calculating, this shaded part here. And then we have the lower limit there, which is 1, and the upper limit, which is 4. And then let's read the first question. Determine the area of the shaded region of the graph of f bounded by the graph and the x-axis between x equals to 1 and x equals to 4. And then let's see, you first write the integral sign, and then you put your lower limit. In this case, you can see lower limit is 1, the upper limit is 4. And then our equation there is negative x cubed plus 6x squared dx, right? Then you can now start to integrate, and then after that is what you're going to obtain. Don't forget, you must put the upper limit on the right hand side and the lower limit below it. And thereafter, the third step, we're going to start substituting what? The upper limit. Where you see x, then we're going to put 4 and 4, and then you say minus. You repeat the very same thing, but you are now going to be substituting with the lower limit, which is 1 in this case. Then you press your calculator, then you're going to get 62.25 units squared. And that's how you should calculate the area using the integral. Then area of a curve below and under the x-axis. Remember the previous examples that we did together? It was area above the x-axis, right? Now let us see if this area that we are calculating is now below or under the x-axis. What are we going to do? Now, to calculate the area below the x-axis, we use what? We are going to say now negative the integral sign having the lower and the upper limit of x dx, right? So the only difference in this one, different is negative. So every time when we're giving a diagram or a graph, and then the shaded part is below the x-axis, then you're just going to include negative before you write what? The integral sign, okay? Then let's get this example and see how do we do that. The sketch below is defined by this f of x equals to 2 negative x. Determine the magnitude of the area if the ordinate equals to 2, x equals to 2 and x equals to 4. And it's very clear from this question that this 2 is going to be lower limit and this 4 is going to be upper limit. And then let's see how do we do that. Then remember, it was very clear that what we are calculating there, the shaded part is below the x-axis. So we're going to say negative the integral sign with the lower limit equals to 2 and the upper limit equals to 4. Then our equation is 2 minus x dx. Then now you start what? You start applying the integral. You integrate it. Then 2 becomes 2x negative x squared over 2. Then on the right hand side, you also include what? The upper limit, which is 4, and the lower limit is equals to 2. Then the third step, where you see x, you just put the upper limit, which is 4, and then minus the lower limit, which is 2. And don't forget, we are still having negative outside. Then hence we have to put this square bracket outside, right? So that it does not affect whatever the answer that we're going to get inside this. And then the last step, you just press your calculator, then you're going to get 2 units squared. So that is the area. Then we have another example. Now, if we can look at this example, we are now having 2 shaded part, the area above the x-axis and the area below the x-axis. And then I try to explain if you are dealing with the area below the x-axis, and then how are you going to write your integral sign. So it's going to be easy for you. And then let's see on how do we calculate that area there, because question says we should determine the area of the stripped region of the graph of f bounded by the graph between what? Between this x equals to -1 from this point here until this point, which is equals to 3. Okay, then we are going to be calculating this area, and then we also calculate this area there, which is area below the x-axis. And we start determining what? Determine the area above the x-axis. And then if you are looking for that, then we can see that the lower limit for this area above the x-axis is -1, and the upper is 1. You write the integral sign, you put everything, and the second step you integrate, then this is what you're going to get. And then this side, on the right hand side, you have the upper limit, which is 1, and the lower limit is -1. And then the third step, you substitute 1 where you see x minus, then you substitute the lower limit, which is -1. Then you just press everything inside your calculator, then you're going to obtain 4 units squared, right? So this is the first area that is above the x-axis. Now let us calculate area under the curve. Then don't forget to include negative. You include negative, then you write everything as it is. And the second step, you just integrate, then you still put what? The lower limit on the right hand side, and then as well as the upper limit. And the third step, you just put a square bracket because we are having -1 outside. Then you substitute everything. Whatever you did on the first attempt when we were calculating area above the x-axis, you do the same. Where you see x, you start substituting the upper limit, and then after you minus, then you substitute what? The lower limit. Then when you press your calculator, then you're going to get what? 4 units squared. Now, because we are looking for the total area of both shaded area or shaded part, then you're going to just say the total area is going to be equals to 8 units squared. You just take the first area and the second area, you add them together, and then it's going to give us the total area of that region, right? All right, thank you very much for being with me on this lesson. It was a very interesting lesson. And then let me just leave you with this nice message, grade 12s, that says study like there's no tomorrow, because if you keep putting off your studies for tomorrow, you'll probably be late. All right. And then thank you very much. Have a nice day.